Hi, my name's Mark Heath, and welcome to my course Microservices Fundamentals. I work as a software architect at NICE Systems, where I'm currently helping to create Azure-based digital evidence management systems for the police. Microservices is a style of architecture where you create autonomous, independently deployable services that collaborate together to create a software application. Microservice architectures are popular because they allow us to build applications that scale, perform well, and enable us to adapt quickly to changing business requirements. In this course, we're going to learn about the key principles and practices that will enable you to be successful with microservices. And we'll be seeing how these principles are applied by exploring an example e-commerce microservices architecture. We'll start off by understanding what microservices are, along with the problems they solve and the challenges associated with them. Then we'll look at how we can architect microservices, making good decisions about service boundaries and data ownership. We'll move on to consider the practical challenges of building microservices, including how we can ensure that developers are as productive as possible. And we'll look at some options for how microservices can communicate with each other reliably. We'll also see how we can apply the defense in depth principle to secure our microservices and how to automate their deployment and monitor them in production. By the end of this course, you'll be ready to design and build your own microservices applications and identify which technologies and practices are a good fit in your context. The demo application that we'll be looking at uses Docker, and although you don't need to have Docker installed, if you do, you'll be able to follow along and try out the demo application for yourself. So I hope you'll join me on this journey to learn about microservices with the Microservices Fundamentals course at Pluralsight. When you're building a modern software application, you want it to perform well, to be resilient to errors, to have a flexible architecture that can adapt to new requirements, and to keep its data secure. Microservices is an architectural style that's grown rapidly in popularity over the last decade, and it has the potential to help us achieve these goals in modern distributed software applications. I'm Mark Heath, and in this course, we're going to explore what a microservices architecture looks like in practice and the benefits that it can bring. In this module, we'll start by making sure that we understand what the concept of a microservice is and what benefits it brings over a more traditional approach, often referred to as a monolith. We'll learn about the limitations of a monolithic architecture and see how microservices offer solutions to some of these problems. But we'll also learn about some of the challenges that adopting a microservices architecture can bring. Although microservices do solve many problems, they also introduce new ones, and so you do need to be aware of this before embracing microservices for your own applications. I'll also introduce you to a sample microservices application, which will serve as an example throughout this course, which illustrates many of the techniques and principles that we'll be learning about. As we move through the rest of this course, we'll look at architecting microservices. How do we decide the best way to divide overall system functionality into individual microservices? Then we'll look at some of the practicalities of actually building microservices. How can we ensure that our team of developers is successful and productive as they implement a microservice architecture, including how to effectively debug and test those microservices? We'll also explore in a bit more detail the options for how microservices can communicate with each other. In particular, we'll look at the approaches of synchronous and asynchronous communications, and how these choices relate to overall system reliability and performance. Of course, in an era of cloud-deployed applications and data breaches, it's essential that we secure our microservices and the data that they operate on. And we'll look at some key principles and techniques that we can apply to protect our system from attackers. And we'll finish by briefly looking at delivering microservices. How can we deploy them into production and monitor them effectively? Right, I've already said microservices lots of times, but I haven't yet explained what they are. So let's talk about that next. What do we mean by microservices? Microservices is an architectural style where autonomous, independently deployable services collaborate together to form a broader software application or system. And that's it. Simple, right? You might even have worked on systems that take this approach without calling it a microservices architecture. Of course, the name microservices also suggests that these services should be small, but there isn't an official size limit. Some teams try to keep them extremely small, maybe just a couple of hundred lines of code, but many of the benefits of microservices still apply even if they're a bit larger than that. But why? Why do we need microservices? Let's look at some of the problems that microservices are designed to address. Microservice architectures are often contrasted with monoliths. A monolith is a software application that typically has all of its code in a single code base, and which all developers collaborate together on that same source code repository. The build artifact is usually a single executable or process that runs on a single host server or virtual machine and persists all of its data into a single database. And the development environment typically uses a single consistent technology, such as what programming language or SDK you're using throughout the codebase. And one of the major benefits of this approach is simplicity. All the code is in one place, so it's easy to find things. There's only one thing that you have to build and run, so it's straightforward for a developer to work on. And when you come to deploy it to production, well, there's just one application to update. And there's nothing inherently wrong with this approach. And if it's working well for you, that's probably a sign that you don't need microservices. Or perhaps I should say, you don't need microservices yet. The problem with monoliths is one of scale. The monolith model works well for single developers or small teams of maybe 2 to 3 developers who are working together for just a few months, maybe to build a small website that handles a modest number of visitors. But what happens when our projects grow much larger? What if we've got 20 to 30 developers and they're working for a period of several years, building a system that will have thousands of users and store massive amounts of data? When we get into this kind of situation, the monolith approach becomes a big problem. For one thing, as a codebase grows larger, there's a tendency for it to become more difficult to maintain due to growing complexity and the accumulation of technical debt. And even if you've made a concerted effort to keep your monolith modularized, often you'll find that these modules end up becoming very entangled and interdependent. When it comes time to deploy your monolith, even a single line code change requires the entire application to be deployed, which is risky and usually involves a period of downtime, something that's becoming less acceptable in the modern era of cloud services that are expected to maintain high availability. Scaling a monolith to meet demands of increased users or large amounts of data is also very difficult. Unless great care has been taken to make your monolith stateless, you probably can't scale it out horizontally. That's where you add additional servers. And so your only option is to scale vertically, where you provision much more powerful and expensive servers. And monoliths require the entire application to be scaled out together, rather than just scaling the individual components that require additional processing power. Finally, with a monolith, you can very easily find yourself wedded to legacy technology. Whatever tech stack you built the original version with is going to be very hard to get away from, as you have to upgrade the entire application to move to a newer framework. And this reduces your agility to adopt newer patterns and practices or to take advantage of innovations such as new tools and services that would benefit your application. Now, perhaps you're thinking, well, my application isn't a monolith. It's made up of several services that can run on different hosts and talk to each other over the network. However, it's very important to understand that just because you have an architecture based on services doesn't mean you're using microservices. It's possible to create a system where you have several services, but they all access data in a shared database, and they're all tightly coupled to each other in such a way that you have to deploy them all together, and any change you want to make to the system requires modifications to multiple services. Systems like this are sometimes referred to as distributed monoliths, and these things are big trouble. They combine all the downsides of monoliths with all the challenges of microservices, and offer very few of the benefits of either approach. So it is important to have a clear understanding of microservices before diving into creating them, or you could end up in a world of pain. Let's see next how a microservice architecture can offer a significant improvement over monoliths.